Well, I'm going to take you on a bit of a deep dive into this ongoing corn waste story out in Mead, Nebraska. And I'm going to tell you why I think that it is imperative that they investigate and do some testing as to whether or not black soldier fly larvae could be used as an alternate option for removal of this waste from the property at a tiny fraction of the current estimated cost. This article was posted a week ago on August 22nd, and it's about how 115,000 tons of corn waste is now going to be headed to a landfill about 24 miles away. The test run referenced in the article title is for 10,000 tons of the corn waste to be trucked to the landfill this fall, before freeze sets in and stops the efforts until starting back up again next spring. Now, this site was closed down in February of 2021. So had they known then about black soldier fly larvae, and had they been able to use them to get rid of this corn, it could have all been gone by now. Without any transportation costs, without any hauling, none of it. Now, one thing that I must mention is that this site got shut down once it was discovered that the corn seed had been treated with an insecticide, which caused putrid odors to permeate throughout the surrounding area. But this is actually what makes my story very interesting, and here's why. So I want to take you over to another web page, and this one is on the website of the National Institute of Health, their National Library of Medicine. And it is a published research article on the effects of insecticides on mortality, growth, and bioaccumulation in black soldier fly larvae. And the bioaccumulation means how much of the insecticide is accumulating in the larvae as they grow towards maturity. So if we skip on down into the abstract, you're going to see that the objective of this study was to assess potential effects of selected insecticides on the growth and survival of black soldier fly larvae and on their safety when used as an animal feed. 6 insecticides with different modes of action were tested in 2 sequential experiments. Okay, so you go a little farther down and you're going to see that the standard black soldier fly larva substrate, which was the corn, untreated, was spiked by the insecticides to the respective maximum residue level, MRL, for each insecticide that is allowed by the European Union to occur in feed. And the black soldier fly larvae were reared on these substrates. Now, I know you're saying, well, that's the European Union. But if you look, the European Union is far more strict with insecticide use than the United States. So I think it's totally fair to use their standard because they're the stricter between the two. So back to our research study. At the concentrations applied of equal to MRL, or 10 times the MRL, which again is the maximum residue level accepted or allowed by the European Union to occur in insect animal feed. 3 of the 6 tested substances did not affect the survival or biomass growth of the black soldier fly larvae compared to the control treatments. Okay, 3 out of the 6 did not affect at all. But here's where it really gets fascinating. At 1 MRL, imidacloprid stimulated the growth of BSFL compared to the controls where there was no insecticide. Okay, it didn't just not have an effect, it stimulated the growth. And what is this imidacloprid? It's a neonicotinoid. And why does that matter? Because neonicotinoids are the insecticides that are used to treat or coat corn seed. It's the neonicotinoids. And I found 3. This one only mentions including 2, but the one in the study, the imidacloprid, is a 3rd one that's used to coat seed. So what has most likely been used to treat this corn seed at this weight site is one of the neonicotinoids, and the one tested in this study stimulated the growth of the black soldier fly larva. So come down here and you're going to read something else that's fascinating and extremely important. The lack of accumulation of insecticides in the larva suggests that there is no risk of larval products, high protein feed, being uncompliant with feed MRLs by the European Union. So basically what this is telling you is we didn't see any significant accumulation of insecticides in the larva at all, and certainly not enough to reach a level that would cause the European Union to say, hey, you can't use these in animal feeds. No, we did not find that to be a problem. So not only could black soldier fly larvae be used to get rid of all the corn, with a little extra effort, it could be used to create tons and tons of high protein, high quality animal feed for chickens, for fish, for hogs, for dogs. Yes, the FDA has already approved black soldier fly larvae for use in dog feed, and you can find a number of different products online right now. We've got to get the word out about black soldier fly larvae, and we need to find out if they could possibly be the answer to this corn waste problem, rather than trucking it all over to a landfill. There are already several black soldier fly facilities that process this kind of volume of organic waste every year or two. Why not set up a field station, like a mobile field station, to process the waste with black soldier fly on site? Black soldier fly reproduce exponentially at a very fast rate. If larvae were not being harvested for feed, then they could reach the numbers needed to process this much waste in one season. What does it hurt to do some tests? How many eggs and larvae would be donated if word went out across the world about this project? Ingenuity could allow for the black soldier fly larvae to process the waste much faster and more efficiently than what most people would have ever thought of. Please, spread the word on this. Promote the World Black Soldier Fly Larva Awareness Week. And hey, if you don't mind, subscribe to my channel. I'd appreciate it if you did.